All right, so we're going to do a little bit of trig review. This assignment could be challenging. If you need to go back and review these notes, then please do. And these might be different than the notes that you got for exponential review or exponent review. You may need to actually take notes on this one. So I'm going to do it my best to explain it. If you have any questions, let me know. So um, let me just first start out with some 30, 60, 90 triangles. Remembering that 30 is pi over 6, 60 is pi over 3, and 90 is pi over 2. And we're going to be working with radians all the time this year. So just know that that's the way we're going to always work. If you think about like that 30, 60, 90 triangle, if you draw a triangle that's 30, 60, 90, and you start labeling some of the sides, here's what you have. This is pi over 3, so that's a 60-degree angle. This is pi over 6, that's a 30-degree angle, and we'll just mark that as a 90-degree angle. If you look at these values, if this value is 1, this value is 1/2, and this value is the square root of 3 over 2. Now those are simplified. So if you use them a little differently, know that that's the simplified version. Now if you have a 45, 45, 90 triangle, remember 45 degrees is pi over 4. And so it's pi over 4, pi over 4, pi over 2. That's the other special triangle that you would need to know by heart. And if you know that one, this is pi over 4. So is this one up here because it's an isosceles right triangle. And in this case, if this is 1, this is the square root of 2 over 2. And this is the square root of 2 over 2 as well. Now, a couple things you need to know, you need to remember. So those are all those values that you have to just know. If you don't know them by heart, you're just going to need to write them down 3 or 4 times. If you keep on going and you say, okay, well, remember that the sine of an angle is the opposite over the hypotenuse. The tangent, or the cosine of an angle is the adjacent over the hypotenuse, and the tangent of an angle, and oftentimes theta is used for the angle, is the opposite over the adjacent. We can also get the cosecant. That's the opposite of the sine, so that's the hypotenuse over the opposite. The secant is the hypotenuse over the adjacent. And the cotangent is the adjacent over the opposite. So knowing that if you're dealing with an angle, it doesn't matter where the angle is. You know, just for example, if this is our reference angle, this is the opposite side. This is the adjacent side. And this is the hypotenuse. Now, couple more things with it is you're going to only have reference angles to use without a calculator of pi over 6, which is 30 degrees, just so you know, pi over 4, which is 45 degrees, pi over 3, which is 60 degrees, and pi over 2, which is 90 degrees. You may have multiples of those. So you may kind of look at it and go, you know, for example, if I said, what's the reference angle of 5 pi over 4, it would be pi over 4. If I say what's the reference angle of 11 pi over 6, it would be pi over 6. So whatever that reference angle is going to be, whatever that pi over the denominator, that's the reference angle. It just means that you have 5 pi over 4 angles, so 5 45-degree angles, or you have 11 pi over 6 angles, or you have 11 30-degree angles. But the reference angle is that pi over the denominator. That's a really important piece, because if you know what the reference angle is, you can go up to these triangles and understand what the value is. Then you just have to decide whether it's positive and negative. So remember from pre-calculus or advanced higher algebra, honors higher algebra, that this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. This is also 2 pi, because we go around the circle. Everything is positive here. Sine is positive here, and everything else is negative. Tangent is positive here, and everything else is negative. Again, of course, the reciprocal one, the cotangent, would be positive where tangent's positive. The cosecant is positive where sine's positive. And the cosine is positive here, along with the secant. So you got to kind of figure out where these things are. And if you can do that, then you're going to be in good shape. So it would be the kind of thing where I said, maybe an example would be, what is the exact value of the sine of 11 pi over 6? So the sine of 11 pi over 6, here's how we're going to find it. What we're going to do is we're going to say, okay, well, if I were to draw this triangle, I know that this is 0. This is pi. Another way of writing pi would be 6 pi over 6. That means when we get all the way back around here to 2 pi, we're actually going to think of it as 12 pi over 6, because that's the same thing as 2 pi, because 12 divided by 6 is 2. So if you're going to draw 11 pi over 6, that means you're just 1 pi over 6 short of 12 pi over 6, which means that you're like right here. This value right here, so this is 11 pi over 6. Now with that being said, we're gonna get something like the following. If we were to write these out, this is 1/2 and it's negative. This is the square root of 3 over 2 and it's positive, and this is 1. So the sine is the opposite over the hypotenuse, or just negative 1/2. And it matches up that the sine is negative in that fourth quadrant. So that's the answer. I'm going to stop this video and let you kind of look back at that one. And then I'm going to give you a second video. So there's going to actually be 2 videos for this lesson. So replay this one if you need more help.